So, thanks for the introduction, Hope. This is us. In case you can't see our faces, you can see them right there. My name is Andy Robbins. My title is Principal Product Architect at SpecterOps. I'm one of the co-creators of BloodHound with Rohan and Will. I don't see him in here. And then, Jonas, you can introduce yourself.
Well, thank you. So my name is Jonas, and I work together with Andy as a product architect at SpecterOps. So yeah, I'm Andy's little helper.
Here's our agenda, what we're going to be talking about. First, we will explain what is ADCS. By a show of hands, who knows what that stands for? Who has configured ADCS? Who has attacked ADCS? Great. So lots of familiarity, but we'll be going through some of the basics as well so that we're all on the same page. We'll also talk about the ADCS components and how they are materialized in BloodHound, let's say. We'll do a demo. And then at the very end, we'll have a brief comment about how BloodHound Enterprise materializes ADCS attack paths and makes things easier for defenders. We are not doing this work in a bubble. We are building on a lot of other people's great work that they have generously publicly shared for free. I'm not gonna read every name off of this slide, but we do want to make sure that we acknowledge that there are other people who we learn from, other people who have done a lot of work in this area. So we have these folks here. And then we have these folks here. Is anybody who was mentioned on one of these slides in the room? No. Okay. All right.
Cool. I guess I'll use that one. Yeah. Cool. So what is ADCS? So Active Directory Certificate Services is Microsoft's implementation of a PKI environment. It's used for issuing and managing digital certificates in Active Directory. And it is located within this container called public key services in the configuration naming context. So like your regular users and groups and computers in Active Directory are located in the domain naming context, where this like ADCS stuff here is located on this configuration naming context. And this naming context here is a forest wide partition. So that means when you install ADCS in an environment, then it is a forest wide thing. So you cannot just install and then only like your users from that domain will be able to use it. It is like useful. You are able to use it from anywhere in the forest. Yeah, so real quick, like what is a digital certificate? It's a concept that uses asymmetric cryptography. So there's a public part and there's a private part. And let's say I get a certificate for myself, then I will be like the subject of the certificate here. And I can share with you the public part, and then I have my private part, which like proves that I am the owner of the certificate. So, for example, if you want to send me a message, you can take my public key and use that to encrypt the message, and then I'll be the only one that will be able to decrypt it, and that way we can secure our communication. Same way, I could also use my private key to encrypt the message, and then you can. You can also use it to assign a message. So you can see that this message was sent by Jonas and not somebody else. You can also use digital certificates for authentication, which is what's very interesting for us. At last, we want to mention that like digital certificates has this certificate chain. So when you obtain a certificate, you obtain it from a certificate authority. So that will be the issuer of the certificate. The certificate authority, or CA for short, also has a certificate, and that certificate has also been issued by a certificate authority, and so on. And that creates this chain of certificates. And this chain here is important because anyone can just create a certificate saying that, like, I'm Andy, or someone else. But what's really important is that the issuer is trusted by the system. So like if you want to authenticate to AD will check that the chain of certificates go all the way up to a trusted root CA, which is the CA that at the end of the chain which holds a self-signed certificate. So the first component we're going to talk about is the root CA, as I just mentioned. And it is the first component that's also created when you install ADCS in an Active Directory environment. It holds this self-signed certificate, so it's not signed by anyone but itself. And it's located in this store called certification authorities within the ADCS implementation. So you can see in the screenshots here that I have 4 root CAs in my environment. And these 4 objects here has a property that holds the certificate of the root CA, and that gets replicated down to the trusted root store on all the domain joined devices in the forest. So that means that every host in the AD environment trusts these root CAs as root CAs. The main purpose of having root CAs is to issue certificates for enterprise CAs, which is the next object that we're going to cover. So enterprise CAs is also known as enrollment services in the ADCS terminology, and they will always chain up to a root CA. You might also be familiar with the terms intermediate CAs or issuing CAs. That's all enterprise CAs in ADCS. So you could have like a 3-tier PKI hierarchy as in the screenshot here to the right. So you have a root CA, and then there's like a level of intermediate CAs, and then there's issuing CAs. The issuing CAs and intermediate CAs are all enterprise CAs, and that's where you can obtain a certificate from. The issuing certificates or the issuing enterprise CAs is typically what you reach out to if you want to enroll a certificate. They're all located in this enrollment services container, and like the root CAs, they are all trusted by the domain joined hosts in the environment. It's just in another folder. It's just in the intermediate certification authorities container, on the local computers. Now, if you want certificates to be used for authentication within your Active Directory environment, then you have to put the enterprise CA certificates into this NT-auth store, which is an object in the ADCS environment called NT-auth certificates. It has like an attribute where you can add the public key of an enterprise CA, and then the AD environment will know that this enterprise CA is supposed to issue certificates that can be used for authentication. So the certificates in this list here will be replicated down to the domain controller. So when you're attempting authentication, then that will be checked on the DCs. So the last component we want to talk about is the cert templates, which is the ones that you're going to use when you're enrolling a certificate. So when you ask an enterprise CA, give me a certificate, you have to specify a template that's used for the certificate. And it holds a lot of characteristics of the certificate that you are requesting. It also specifies some properties for how the enrollment has to happen. And it also holds some stats for like how long this certificate is going to be valid and so on. An organization can have like a lot of certificate templates, but it's only the published one by the enterprise CAs that you can actually enroll in. So if an organization have like, let's say, 3 enterprise CAs, then you might be able to enroll a certificate from a specific template on just one of the enterprise CAs, depending on how they're configured. There's a couple of, there's actually a lot of attributes of the certificate templates that are interesting for us as attackers and defenders. Some of them that we are very interested in is, for example, the ones that specifies whether or not a certificate template can be used for obtaining a certificate that can be used for authentication. And that is stored within these enhanced key usage OIDs, so EKUs for short. I have a list here of the 5 EKUs that allows for authentication. So it's interesting for us to see if these EQs are present in the certificate template, so we can know like whether or not you can use it for authentication. Then there's also these issuance requirements that you could set up on a certificate template. So that means that, for example, if you enable manager approval, you might have the permissions to enroll in a certificate template. But if manager approval is set to configured on a certificate template, you'll not get the certificate immediately. A manager has to log into the enterprise CA and approve that request before you can actually obtain it. There's also another option under issuance requirements, which is the authorized signatures. So you can also require users to present another certificate when you're asking for a certificate that holds some issuance policies that specifies that you actually have the rights to obtain this certificate. Yeah. Then the last one is probably one that you have heard about if you have explored the escalation 1 abuse primitive. And it's a flag that you can set under the subject name where you specify that the requester of a certificate can supply the subject name. That basically means that when I'm enrolling a certificate, so instead of like letting the environment figure out like which properties should go into the certificate, like who does the certificate represent, you can supply it in the request. So I can just say, hey, I'm Jonas, and I want a certificate as Andy, and the enterprise will say, sure thing, here you go. Yeah, so it's a quite dangerous setting. Cool. So here is a simplified diagram for how enrollment and authentication works with a certificate. So as a principle, I'll say, I want a certificate of this certificate template here. And the enterprise CA will check that, first of all, do I have this certificate published? And if so, does this principal have the enrollment rights on the certificate template to actually allow for enrollment? Also, I'll need to have enrollment rights on the enterprise CA itself. And then we'll also, of course, check these issuance requirements that I talked about before. If all these things align, then I'll get the certificate that I've requested. Then, if I want to use this certificate for authentication, let's say over Kerberos or PKInit, I'll present this certificate to the domain controller, and the domain controller will verify that this certificate here is trusted by, or is issued by an enterprise CA, which is trusted for NC authentication. It will check that all the certificates in the certificate chain are trusted all the way up to a root CA for the environment. And it will also check that the certificate has an EQU that allows for authentication. There's also some extra checks of like figuring out if it's revoked or if it's even valid. And then there's also the process of figuring out if it's the right principal that I'm authenticating as. If you have a regular certificate, you cannot just say, hey, I want to authenticate as another user. It will also do some validation there. But yeah, if everything aligns, you will get a TDT, Kerberos service, or sorry, Kerberos session ticket, and then you have been authorized. So how did we get all these things into BloodHound? We've introduced 5 new node types in BloodHound. We have already talked about 4 of them. There's a 5th one called ADCS, which we have included in the graph for now, but it's not something that we use. So yeah, you can focus on the 4 other ones. And here you can see where we have mapped out the locations of these objects in my lab environment here. So you can see that we have all the root CAs, the enterprise CAs, these ADCS, and we have the certificate templates. Unlike your users and computers and groups that can be located in many different containers or OUs in Active Directory, these objects are always in the same location under this configuration naming context. And traditionally, SharpHound, the collector for objects of Active Directory for BloodHound, hasn't been able to collect data from the configuration naming context, so we had to expand it to collect these things. It's actually very easy to collect these things because the configuration naming context is replicated to all the domain controllers in the entire forest, and authenticated users have read access to this partition here. For every new node type, we have also added an entity panel, like you have probably seen it for the existing node types. So in here, you have included the information that is relevant for us as security principles and information you need in order to either abuse it or figure out whether or not it can be abused. So for example, here for the certificate template, you can see that marked with yellow that there's no authorized signatures required for this certificate template. And there's no requirement for manager approval. So that means that, the users that have enrollment rights on this certificate template can obtain a certificate immediately. You can also see with marked with green, we have 3 different attributes. They're all set to the same EQU. The reason for that is that in Active Directory, there's actually 2 attributes that defines the EQUs that the certificate template has. And then we have included a 3rd one called effective EQUs, which is actually the ones that will be effective on the certificate template. Because most of the time, these 2 attributes in Active Directory, they contain the same content, but they can be different. And we had to figure out which one is it then that take precedence and is effective on the certificate template. And the logic is kind of complicated. It depends on the schema version and whether or not one of them is set to null or not. So instead of you having to learn that logic, we've included this property that just holds the effective EQ. So you don't have to deal with that. In the same way, we've also included another field called authentication enabled. So you don't have to learn the EQUs that allows for authentication. We can just tell you that this certificate template enables authentication. As mentioned before, there's so many attributes on a certificate template that are interesting for us as security principles, and the naming of these attributes are not always easy to understand. So we have tried to give in the entity panel, give these properties meaningful names, but you might also still need to know what are the underlying LDAP properties that they come from. So in our documentation, we have these tables here that show what is the name of the field in the entity panel, what is the name of the attribute in the BloodHound database. So if you want to write a cipher query, you can look up the name in here. And also what is the directory name of the property. And there's also a short description, so you can see what it actually represents. We're also adding a lot of new edges in BloodHound for ADCS. Most of them are going to be these types that we call non-traversable edges. Here's a full list of all the non-traversable edges we have added so far. Before we dive into some of them, I want to make sure that we are on the same page regarding what is a non-traversable edge, because it's something that you might not have stumbled upon using BloodHound so far. So first of all, a traversable edge is the ones that you typically see when you search for an attack path in BloodHound. So if I search from my user to domain admins, I might see admin2 edges, force reset passwords, and so on. These non-traversable edges are edges that are not abusable on their own. So they are not included in pathfinding when you use pathfinding. But we use these edges here to construct other edges. The most simple example is probably the get changes and get changes all and DC sync. So a principal can have get changes and get changes all on the domain head object. And if you have both of them, that allows you to perform the DC sync attack where you obtain all the password hashes for all the users and computers in the environment, but you need both of them. So we model this by, so when you search for an attack path like this here, you might see that your user here has a path to the domain that includes a DC sync edge, but under the hood, what we are creating is these get changes and get changes all edges from the principals that actually has these permissions in AD. And after we have ingested all the edges, we do what we call post-processing, where we create these more advanced edges that rely on other edges. So in this example here, you can see I've run a Cypher query that shows both get changes and get changes all and DC sync. So we can see how this user here actually has the permissions to perform DC sync. And here's some of the non-subversible edges that we have included for ADCS. So let's start out from the right. We can see we have this domain node here, and it's my dumpster fire lab environment. And we have a root CA, which has a root CA4 edge to this domain. So that tells us that this root CA node here, it belongs to this domain. There's likewise also an NC store, NC auth store, which has an NC all store 4 edge to the domain. And then we have in the middle of the screen 2 enterprise CAs. They both have an issued signed by edge that goes up to the root CA. So that tells us that these enterprise CAs here, they are issued and signed by this root CA. So they chain up to a root CA for the domain. They're also, both of them are also in the NC auth store. So they have a trusted for NC auth store edge directed to the NC auth store. Then we can see that authenticated users have enrollment rights on the enterprise CAs. So everybody basically in the environment can enroll certificates from these 2 enterprise CAs. And then there's 3 published certificate templates of these 2 enterprise CAs where domain users has enrollment rights on these templates. So that all means that domain users can enroll in these certificate templates here, and they will be trusted in the environment because the enterprise CAs chain up to a trusted root CA for the environment. And if these certificate templates here allow for authentication, then they'll be accepted by the environment because the enterprise CAs are also trusted for NC authentication. Each of these new edge types also have an entity panel. So if you click on them, you can see some information about like what it means, how it can be abused, and there are some additional references if you want to learn more about these new edge types. Cool. Yeah, that's probably a good idea.
Okay, so we're going to do a demo, and we're going to show from the attacker perspective how you can use BloodHound CE, which is the free and open source software, to discover, analyze, and execute an attack path that traverses all of this ADCS infrastructure that we're talking about, that Jonas described how we model in the product. So, pro tip, live demos are overrated and too risky, so we have a video demo for you. I don't expect you to be able to read every word on the screen. This talk is being recorded and will be put on YouTube at a later date, so it'll be much easier to see the actual text then. Otherwise, I will do my best to explain what exactly it is that we're looking at. So in this scenario, we are emulating a red teamer, an attacker, an adversary of some kind. And we want to become domain admin. Who doesn't want to be domain admin? And BloodHound is going to help us find an attack path that traverses the ADCS infrastructure to land at an ability to impersonate any principal in the forest, including all of the domain admins. So here we have an RDP session open on a system that, let's say, is like an initial access system that the adversary has compromised. On the left, we have our BloodHound CE interface. The first command that we're going to run will just prove that our, oh, I'm sorry, I'm getting ahead of myself. So the first thing we're going to do is we're going to try to find if there is a path from our initial access user to the domain admins group. And so this pathfinding feature where we can start from any node in the graph and we can end at any node in the graph is a very obvious core function of BloodHound. And behind the scenes, what that function is doing is it is doing a shortest path query. So it's doing something like A* or Dijkstra's algorithm. Now, Jonas mentioned how we are taking all of these non-traversable edges and we are constructing traversable edges or attack path edges, if you will. One of the reasons that we do that is these pathfinding algorithms, they are very, very effective and they're very, very fast when edges are, let's say, static in the database, and where patterns between these arbitrary nodes are static. So at query runtime, it is extremely dangerous from a performance perspective to be doing this kind of analysis that Jonas is talking about. So the pathfinding algorithm can't do the work of discovering what are all of the configurations on all the templates? What are all of the CAs that are trusted for NT auth? What are all of the root CAs for the domain? We can't do that at query runtime. We have to do that before the query is actually run. And so the benefit of that is that when you click on the pathfinding feature and when you run the pathfinding feature, it runs most of the time in less than a second. Whereas if we were having to do this analysis at query runtime, you're literally talking about it taking hours and hours and hours to finish. So I don't know about you, but I prefer my tools to give me instant feedback. And so we've worked hard to make that happen in the product. Not only that, but it also makes the resultant attack path much easier to read. So let's read this attack path together. At the top, we have demo user or demouser. And so that's our initial access user. That user is a member of the domain users group. That group has the ADCS escalation 1 primitive against the domain here. The domain is obviously going to contain all of the principals in the domain. So it contains the users container, which contains the domain admins group. So as an attacker, what this tells me is that as demo user, I can do escalation 1 against this particular domain and impersonate any principal in that domain, including anybody who's a member of the domain admins group. There's actually, correct me if I'm wrong, but there's no way to exclude principals from impersonation with what we're talking about here. Jonas showed how in the BloodHound interface, you can click on an edge and get help information about that. So maybe you're new to Active Directory and you're not very familiar with like security group delegation concept. So you can click on the member of edge, for example. You can get just general statement about what that means. You can also click on the abuse accordion, the OPSEC accordion, or the reference accordion to get relevant information based on what those things are showing. Additionally, you can do the same thing for this new ADCS escalation 1 edge. So I hope that one of the takeaways you got from what Jonas was going through is that ADCS is extraordinarily complicated. And anybody who has architected or worked with ADCS, I think, would agree with that statement. So as a red teamer, as a defender, you need concise information that explains exactly what is being told, because keeping all of this straight in your mind, at least for me, is not really possible. So one of the most important jobs that we have as product architects is to understand what is the job to be done by a red teamer, a pen tester, a defender, and to understand what is the friction involved in that job, and do what we can in the product to reduce that friction as much as possible. So we want to understand what is standing in the way of a pen tester doing escalation 1. What is standing in the way of a defender securing ADCS? And in the product, we manifest how we reduce that friction, how we get those things out of the way for you. So that's what we see here. You can also see example abuse commands for if you are operating from a Windows system or a Linux system. OPSEC considerations will tell you what are the artifacts that will be created when you are actually performing that attack. And then critically, what we just clicked on there is this new accordion item called composition. Now remember that this escalation 1 edge is what we call a traversable edge. But it is constructed from all of these other edges, which we see now, that we call non-traversable edges, or maybe composition edges, could be a better term. And so when you click on composition, you actually see the atomic nodes and relationships from which this escalation 1 opportunity emerged. And this is what you'll see also for escalation 9, escalation 6, and escalation 4, 7, and then in the future, escalation 5 as well. Here's the full view. It's kind of in reverse order, so we can change the view there. So the domain users group has escalation 1 against the domain. And the way that it has that is this principal has enroll rights on this template CT1. That template is published to an enrollment CA here. Now, having enrollment rights on the template is not enough. You also need enrollment rights on the CA that the template is published to. So the domain users group is a member of, well, kind of a member of the authenticated users principal. Effectively it is. And the authenticated users principal has enrollment rights on the enrollment CA. Therefore, all of the domain users too as well. This enrollment CA is an enterprise CA for this root CA. And in LDAP, these are actually distinct objects. This could be more complicated. So if we had 3-tier PKI, we could actually see several CAs in this chain. The enrollment CA is trusted for NT authentication by the NT auth store, which is the NT auth store for the domain. Now, there's more to it. What we also do is we understand the properties of this certificate template to understand based on the EKUs, the schema version, et cetera, that escalation 1 is possible through this template. So you don't need to pick through all the details of all of these nodes to understand that escalation 1 is possible. We've done that work for you. And I believe we've done it pretty accurately. Yeah, accurate enough. No, it is. We actually worked extremely hard to make sure that it's accurate. Yeah. Again, you can click on these edges to get information about what these things mean. Okay, now let's go back to our adversary perspective. So let me back up a little bit. Who's done escalation 1 on a pen tester or red team? A few people, okay. When you execute escalation 1, there's information that you need to feed into a Rubeus command, or if you're using some other command, in order to pull off the attack. With Certify. So with Certify, for example, you need to target the specific CA that is involved in escalation 1. And you also need to specify the display name of the template involved. And then you also need to specify the, I think that's NT4 format, the NT4 format of the principal that you want to impersonate. And so in the interface, in the BloodHound interface, we've tried to make it as easy as possible to be able to just copy and paste from BloodHound into your command to, again, reduce that friction so that you're not chasing information here, there, everywhere. And so that's what we're looking at here. These are the properties that Jonas was talking about. So you can verify that information if you would like. And then to identify a principal that we're going to actually impersonate, we can click on the domain admins group. And then in the domain admins entity panel here, we can click on members, which will show us who are the principals that belong to that group. And so in that group, we have this user called researcher. That's going to be the principal that we're going to impersonate as our demo user principal. Okay, getting back into the actual attack steps. The first thing that I'll do here is I will do a simple proof that I'm not a domain admin already. And so I'm just trying to dir the $$ share on the domain controller, which you by default have to be an admin to do. I try to do that, and you can see that we get access is denied. So that proves that we're not already a domain admin. Then we're going to use Certify to enroll in this certificate, which will then result in that file, or it will result in a certificate file being on disk in our current working directory. In that command, we're specifying the CA, the template, and the principal that we want to impersonate. We're going to take the resulting certificate and we're going to manipulate it into a different format using OpenSSL. This password here, I'm just making it like ASDF or something like that. And then this resulting PFX, I will take from my Mac OS system, and then through the RDP channel, I'll put it on disk on the Windows system. You can also just do this in Windows. I'm just kind of, I don't know. I like my Mac terminal, I guess. There's the file on disk. So then, now we'll use Rubeus to use that certificate to request a TGT as the researcher user. And this template, the resulting certificate, it has a subject alt name for the researcher principal. And so because of that, and because of the fact that the CA involved is trusted for NT authentication, and because the CA involved is trusted as a root CA, the domain controller will issue back the TGT, which will be valid for authentication as the researcher user. I'm supplying the password that I said earlier, which is just like ASDF. And then we're also doing /PTT pass the ticket so that the ticket is just immediately loaded into memory. That's done. And then if we did klist now, we would see that ticket is loaded in memory. And finally, we will again go back and we will dir out the $$ share on the domain controller, and we can see that now we can access that, and that proves that we're authenticated as a domain admin. Now, as a pen tester, as a red teamer, when you deliver a report to a customer and you say, hey, there was escalation 1 in your environment and I executed it, if I'm the customer who's receiving that information, my first question is going to be like, okay, that's great. What do I do about that? And then my second question is going to be, okay, great. Did you also analyze all of the other templates? Did you find all of the escalation 1 scenarios? So we're also working, we have worked to make answering those questions with the FOSS tool as easy as possible. Also, just other generic hygiene questions we want to be able to answer. For example, on this template, if we pull up the entity panel for this template, which was susceptible to escalation 1, we can look at the inbound object control, which will show not only who has like generic all, but also all the principals that have enroll rights on that particular template. And that information will be more useful to a defender for being able to make some remediation actions. We can also do the same thing for a CA. So here for the enterprise CA object, we're looking at inbound object control again, and we can see the principals that are involved that have control of the root CA or the enterprise CA, either in a material way because they have like managed CA rights or generic all, or the principals that just have enroll rights. And I believe that's going to be the end of that. Yep.
Yeah. If you go back to the end of the presentation, there's actually also, it may be too small to see, but there's a red node, which is a computer node that has a bunch of edges to the enterprise CA. That'll be the CA host itself, where the enterprise CA is actually running, which is also linked up to the enterprise CA. So you can actually quite easily find that host and see like paths going through there. So we can see there's also an inbound edge from a group going up to that object for the computer object. Yeah, so that's also useful. We have included a couple of predefined queries under the Cipher tab on the Explore page that can actually highlight the PKI hierarchy and also like which computers host DCS and so on.
Back to the deck.
Yeah, so we have also introduced a couple of things in BloodHound Enterprise. So in BloodHound Enterprise, we have the same nodes and edges as you have in the open source version. What we do have in BloodHound Enterprise is that we have findings. So you don't have, as a BloodHound Enterprise customer, to look for these edges. If there is a principal which is marked as non-tier 0, that has the opportunity to perform escalation 1, that will show up as a finding on this attack paths page here. So you can immediately see like that authenticated users and domain users can perform escalation 1 in my environment here. You can also see the exposure for the findings. So you can see like how many principals can actually abuse this, and of course it's going to be a pretty high number if it's authenticated users. With the new findings, we also have recommendations for remediation. And as these kind of attack paths for ADCS are quite complicated and has a lot of requirements, there's also a lot of opportunities for actually like breaking the attack paths. For example, you could just delete the root CA and then it'll not be possible to perform escalation 1. But it's probably also going to break a lot of other things if you do that. So we're trying to like guide as much as possible to figuring out like what is the best solution in your scenario. So for escalation 1, we have like 6 different ways that we suggested you could potentially remediate the issue. And this is just a screenshot of the top. And underneath it, there's like the details of how you can actually perform the remediation. And that's it.
Yeah, I think we have time for questions, maybe. Any questions? Should we give the mic or? Yeah. Okay.
Questions? Okay. Hello. Ooh, well, okay, so I was wondering, would you be able to go back to the slide that you had going over the whole like BloodHound custom query being like shortest path here? Would you be able to just like walk through that?
Shortest path. What's
It
that?
had like a full query that like you could like copy paste or something that like actually had the, yeah, right there. Yeah, could you just like briefly go through that?
This right here?
Yeah.
Sure. So are you familiar with the DC sync attack? Yeah, so DC sync is enabled by several different combinations of privileges. If you're a local admin on a DC, which let's not debate what that means right now, but you can DC sync. But more atomically, more specifically, DC sync is enabled by the combination of two different privileges, which are DS get change, DS get change. Oh, geez, get changes and get changes all is a short name. One of those is not enough to be able to pull out NTLM hashes from the DC, but the combination of both of them is. And so these two different writes, these are actually what domain controllers have against the domain that enables domain controllers to do credential replication to each other. So a domain controller computer object is a member of the domain controllers group, which has one of these, and it's also a member of the enterprise domain controllers group, which has the other one. So it is the combination of those two that enables DC sync. And in the real world, we've also seen situations where maybe a principal has both of these through different group memberships as well. So this cipher query is showing from the domain user, so we're specifying on line 2 that the name of the user is domain user at dumpster fire. And then the P variable on line 1 is being assigned to the result of the pattern, which starts from U and then traverses through any number of member of edges, and then traverses through either DC sync get changes or get changes all edges to any domain labeled node in the database. And then line 3 is returning those patterns. And so this shows us both the post-processed edge, which is DC sync, and then it also shows us the non-traversable edges, which are get changes and get changes all. Does that answer your question? Okay. Right here. She'll bring the mic to you.
So I have kind of a cheeky question, and there's a few parts to it. So one of the things that slows us down when we're like, so I'm a red teamer, when we go to exploit like ESC1 is actually nothing to do with the certificate side at all. But like we see MDI, Defender for Identity, a lot. And so we're looking for like, can we work out which domain controllers don't have the MDI agent on? Because then obviously you could do your Kerberos auth against that. Failing that, at the moment we just sort of assume if we see Defender for Endpoint, we assume MDI everywhere.
Yeah.
And then we try and use the certs against like LDAP instead. And we'll do like, we'll look for disabled domain admin accounts, and then we'll just change their password and re-enable them, stuff like that. So is there anything in BloodHound for maybe helping us out there, like maybe looking for domain controllers that may be more likely that we could go against, or potential other routes, like other places we could use the certificates that aren't Kerberos for getting around?
Well, I guess if you're not using Kerberos, you could be doing like you could be signing something. You could be like signing some binary, I guess. You could do that analysis in BloodHound to find, you know, what templates your current principal can enroll into effectively, and then you could go through those one at a time, and you could see what the EKUs are, so you could understand like this one is for this one's for that, this one's for that. But your first question is more about, you know, can BloodHound help with defense evasion? I guess no, it's not really part of what we're trying to accomplish with BloodHound. So we want to model what are the attack paths, but then like, for example, we don't model layer 2 or layer 3 at all. So if there's network segmentation, you're kind of on your own. And it's the same thing with defensive evasion. Is we're not going to try to like, you know, for example, like list processes on a DC and be able to map this process as this EDR agent and stuff like that. So no, sorry.
Yeah, I think there's one thing that could be interesting is like if you have a multi-domain forest and there might be some domains that they don't really use that much. It's just something that they are like in the process of decommissioning, and it has like been like that for the past 10 years. But it still exists. So it could be like you could look for, I believe we have introduced a new edge, or we have called DC4 that links domain controllers to the domain. You could find that before, like with the distinguished name, but you could look for like all the domain controllers in the forest and try to figure out like which domain looks like that it's not really being used. So it could be that they have not installed like the MDI agent on those domain controllers, and then like compromise domain admin in that domain, and then yeah, from there you can probably quite easily escalate to enterprise admin, and yeah.
I can see that we're over time, so maybe we have time for one more question. Oh,
Thanks.
Just wanted to see, could you talk a little bit at a high level about how you about your architecture for that processing non-traversable edges into traversable edges, and just give a feel for how much time of your sort of ingest that takes?
Do you mean like technical architecture, or do you mean like our like product development process architecture?
Technical.
Yeah. So data is ingested into BloodHound, and so that's with like a JSON formatted file that goes through first the ingest process. And the ingest process is basically naive, I would say, and generic in that data coming in goes into the database. And there's no logic necessarily beyond mapping this JSON property will be interpreted as this kind of variable, like it's a string, it's an integer. And then maybe there's translation as far as taking like Windows epoch time and converting that into Unix epoch time, for example, right? So maybe it's not as naive as I said. So data collection, ingest, and then for BloodHound Enterprise does a reconciliation process. And the reconciliation process is taking the information that's already in the database, comparing that to the new information coming in, and then reconciling that so that what is in the model is actually the most up-to-date information. BHCE doesn't do that because it doesn't really fit the use case for Red Team. After reconciliation is the post-processing step. So post-processing waits for reconciliation, and it waits for ingest to be totally done. And at that point, in the database, we have the non-traversable edges that are all there. And all the nodes, the properties are all there. So the enroll edges are probably the only ones here that are, well, and member of are the only ones that are like non-traversable. Or I'm sorry, that are not post-processed. They're not created in post-processing.
Publish 2 is also created at ingest. But then we have like the post-processing logic has like a specific order because we need the issued signed by edges and the trusted for NT auth edges to be created first before we can create the escalation one. So that's the first step. We check like there's like on the enterprise CA there's a property containing the certificate chain, so we can create that link to the root CA from the enterprise CAs. And yeah, there's also this reference attribute on the NT auth store that makes it possible to create the trusted for NT auth edge. And when we have everything in place that you can see on this screen, then we take for every domain node, we find the enterprise CAs that are trusted for NT authentication and change up to a root CA. And then for each of them, we look through all the certificate templates that has like a publish to edge to that node. Then for each of them, we find all the principals that have enrollment rights on both the enterprise CAs and also on the certificate templates. And then we have some pretty advanced logic that I don't really know how it works that finds like the intersection of like the principals that have enrolled on both the certificate templates and on the enterprise CAs. And yeah, we also filter out all the certificate templates that doesn't meet the requirements for escalation 1. And by the end, we will have this escalation 1 edge created.
Yeah.
Yeah.
And we create that directly from the principle that has everything Jonas just said, chaining up to the domain. We create that from that user to the domain.